Hi guys, so today we're going to solve this problem, and this will be the first incomplete combustion problem na sasagutan natin for our series of lecture videos for stoichiometry of fluid combustion. So alam natin that this is an incomplete combustion dahil we will have a presence of carbon monoxide. Okay, so basahin muna natin yung problem natin. A fuel oil consisting of 90% carbon and 10% hydrogen is burned in an engine supplying 100% excess air. 80% of the carbon in the fuel goes to carbon dioxide. So 80% lang ang nag-proceed to complete combustion and the rest is carbon monoxide. So 20% ng ating fuel is turned into carbon monoxide. All of the H2 is burned to H2O. Calculate the ORSAT analysis of the flue gas. So, sabi natin dito sa ating fuel oil, we have 90% carbon and 10% hydrogen, ano? And then we supplied air, okay, with 100% excess. So, we have air plus 100% excess air. Okay? So, ang kailangan nating makuha is yung ORSAT analysis natin, ano, dito sa ating flue gas. But in order to solve for this problem, we need to set a basis. Okay? So, let's use as our basis a 100 pounds of fuel oil. Okay? And since we have 100 pounds of fuel oil, makukuha natin ngayon yung weight ng carbon. So, ang weight ng carbon natin is 90% of our fuel oil. So, we have 100 pounds times 0.9. So, this is equal to 90 pounds of carbon. And the weight of hydrogen is 100 pounds times 0.1, which is equal to 10 pounds of hydrogen. Now, in order to use this sa ating mga combustion reaction, we need to convert this into number of moles, right? So, the number of moles of carbon is equal to 90 pounds divided by its molecular weight. So, we have 12 pounds of carbon per 1 pound mole of carbon. And this will be equal to, check natin, we have 90 divided by 12, which is equal to 7.5. So, we have 7.5 pound moles of carbon. Now, what is the number of moles of H2? No? Kasi yung mga H2 natin ang na-convert into water. Okay? So, hydrogen is diatomic, kaya kukunin natin is yung H2. So, we have 10 pounds of hydrogen divided by its molecular weight, which is 1 pound of hydrogen per 1 pound mole of hydrogen. And then since it is a diatomic molecule, so we will have 2 pound mole of hydrogen per 1 pound mole of H2. Diba? Okay, so our units will be cancelled out. Ganun din dito kanina, no? So, we'll solve for the value of H2. So, we have 10 divided by 2 lang, no? So, we have 5 pound moles of H2. Okay, so, kunin na natin yung ating combustion reactions. Okay, this is our reaction for complete combustion. No? So, our carbon will react with O2 to produce CO2, right? So, how many moles of carbon do we have? Okay, so we have 7.5 pound mole of carbon. So, we have here 7.5 pound mole. So, 1:1 tayo. So, meron din tayong 7.5 of O2 and 7.5 of CO2, di ba? Eh, paano naman sa ating H2? So, we have H2 will react to 1/2 of O2 producing H2O. So, ilan ang moles ng ating H2? We have 5 pound moles. So, we have 5. So, H2 is 1:1 sa ating H2O. So, we have 5. And we have 1/2 of O2 here. So, 5 divided by 2, we will have 2.5 pound mole here. Okay, so katulad nung natutunan natin last time, in order to get the theoretical O2, we need to get the number of moles ng O2 required for complete combustion, di ba? So, dyan natin makukuha yung ating theoretical O2. So, our theoretical O2 is equal to 7.5 pound mole plus 2.5 pound mole. So, our theoretical O2 is equal to 7.5 plus 2.5, which is 10 pound mole of O2. Okay, so yan ang ating theoretical O2. Now, how are we going to get yung supplied O2? So, we know that our theoretical O2 is 10 pound mole. So, meron tayong pumapasok na 10 pound mole ng air. Pero, naglagay tayo ng excess air, which is 100% ng ating theoretical air, no? So, what we'll do here is that we have 10 pound mole of O2. Yan yung ating theoretical O2. But then, nagpasok tayo ng 100% excess air. So, therefore, we will have 1.0, which is 100%, no? So, itong 1.0 natin is the 100% excess air, no? So, this is 100% of our theoretical O2, which is 10 pound mole. Okay? So, therefore, our supplied O2 is actually equal to 20 pound mole of O2. Okay? So, yan ang ating supplied O2. Now, why did we get itong supplied O2? Bakit kailangan nating makuha yan? Okay, because we're going to check this, no? If we'll check this material balance here, ano yung magiging component ng ating flue gas? So, alam natin na meron tayong carbon dioxide, diba? So, we have CO2. Then, nagkaroon din tayo ng CO. All of our hydrogen here sa ating fuel oil is converted to H2O. So, wala tayong H2, no? Dito sa ating flue gas. Okay? Because everything is converted to water. And then, meron tayong pumapasok na air. So, we have theoretical air, okay, na kailangan natin for complete combustion, pero nagbigay tayo ng excess air in order to ensure na magkakaroon tayo ng complete combustion. So, kung meron tayong excess air, so therefore, we will have unused O2 dito sa ating flue gas, no? Kasi hindi lahat ng oxygen natin magagamit natin for combustion. Nagbigay nga tayo ng excess, di ba? And now, dahil ito ay air, so we know that the air is composed of oxygen and nitrogen. So, we will have nitrogen here. Okay? So, yan ang dahilan kung ba't kailangan nating makuha yung supplied air. Dahil kailangan nating makuha yung value ng nitrogen dito sa ating flue gas. So, alam na natin yung value ng supplied O2. Ngayon, makukuha na natin dito yung value ng ating nitrogen. So, we have supplied N2 is equal to 20 pound moles ng O2. Then, mumultiply natin siya sa fraction ng nitrogen to oxygen, no? So, we have, for every 21 pound mole of O2, we have 79 pound mole of N2. Okay? So, yan yung portion ng ating nitrogen and oxygen sa air. So, di ba? Ang ating air is composed of 79% nitrogen and 21% oxygen. Ano? So, if we're going to check our units, this will be cancelled out. So, our supplied N2 will be 20 times 79 divided by 21. So, let's do that. 20 times 79 divided by 21. So, we have 75.23, no? Or 24. 75.24 pound mole of N2. Okay, so pwede na natin isulat yan sa taas. 75.24 N2. Pound mole. Okay? So, gaano karaming CO2 meron tayo dito sa ating flue gas? So, we need to get our actual combustion, no? Okay, because ang kinuha natin dito sa taas, this is the theoretical, no? Or the complete combustion. But, actually, hindi naman lahat ng carbon natin is na-burn. Ang iba ay na-convert into carbon monoxide. So, let us again do our reaction here. Okay. We know that only 80% ng ating carbon is converted into CO2. Okay, so it's written here. 80% of carbon in the fuel goes to CO2. So, gaano karaming CO2 ang na-convert into CO2? I mean, gaano karaming carbon ang na-convert sa CO2? So, we know that the number of moles ng carbon in fuel is equal to, nasolve na natin kanina yan, no? Sa itong number of moles ng carbon is 7.5 pound moles. Okay, so we have 7.5 pound moles ng carbon sa ating fuel. Now, the number of moles of carbon converted to CO2 is only 80% of this, no? So we have 7.5 pound mole ng carbon times 0.8. Okay, because this is 80%. Okay, para sa mga nagtatanong kung saan natin nakukuha yan, no? So this is 80% of the carbon in the fuel, no? So, in order to know its value, calculate natin 7.5 times 0.8. We have 6 pound mole, no? So, we have 6 pound mole of carbon. So, ito lang yung number of moles ng carbon na na-convert to CO2. So, therefore, ito ang ating carbon, which is 6 pound mole. 1:1 to O2. So, we have 6 pound mole. And for CO2, we have 6 pound mole. Okay? So, yung ibang carbon natin is converted to carbon monoxide, diba? So, we have carbon plus O2 converted to carbon monoxide. So, to balance our reaction, we will have 1/2 of O2 in here. So, gaano karaming carbon naman ang na-convert into carbon monoxide? So, the number of moles of carbon that is converted to carbon monoxide is equal to 7.5 pound mole ng ating carbon sa fuel times 20%, no? Because the remaining 20% of the carbon in the fuel is converted to carbon monoxide. So, this is 20% of the carbon na nasa fuel, ano? So, this will be equal to 7.5 times 0.2, which is equal to 1.5, no? So, we have 1.5 pound mole. And for carbon monoxide, 1.5 pound mole. And para sa ating O2, which is, we have 1:1/2, no? Yung ratio ng carbon sa O2. So, we have 1.5 divided by 2. So, we have 0.75. Okay? Ng ating O2. are used to convert it to CO. Okay, so katulad nung nauna, yung ating H2 is converted lahat into H2O, no? So we have H2 plus 1/2 ng O2 is converted to H2O. And our H2 is 5 pound mole, no? So we have 5 pound mole. 1:1 sa water. So 1/2 is 2.5. Okay. So, gaano karami yung actual na nagamit nating O2? So, actual O2 used. Gaano karami? So, para malaman natin kung gaano karami yung actual na nagamit, we need to add all of the O2 that is used in converting carbon to CO2, converting carbon to CO, and converting H2 to H2O. So, we need to have 6 plus 0.75 plus 2.5. Okay, so yan ang ating actual O2 use. So, we have 6 pound mole ng O2 plus 0.75 pound moles ng O2 plus 2.5, okay? 2.5 pound moles of O2. Okay, so actual O2 used is equal to, calculate natin, 6 plus 0.75 plus 2.5. So we have 9.25 pound mole of O2 is used. Okay? Actual, no? Actual yan. Now, sabi natin kanina, meron tayo ditong unused O2. Di ba? Dahil hindi naman lahat ng ating oxygen is nagamit for combustion. So, we have supplied O2 of 20 pound moles. Okay? So, our supplied O2 is equal to 20 pound mole of O2. Now, the unused O2 is equal to supplied O2. Ito gaano karaming O2 yung pinasok natin sa ating system minus yung actual na O2 na nagamit. So, actual O2 use. Okay, so therefore, our unused O2 is equal to 20 pound moles of O2 minus yung actual O2 use, which is 9.25 pound moles of O2. So therefore, our unused O2 is equal to 20 minus 9.25. So 20 minus our answer, which is 10.75 now. So we have 10.75 pound mole of O2, which is not used. Okay, so i-post natin yan dito sa ating flue gas para hindi na tayo mahirapan. Our O2 here is 10.75 because this is unused. Our water, katulad din ito because all our H2 is converted to water, so we have 5 pound mole of water. And then, yung ating CO2 na na-form and CO, we already got that here, yung actual combustion natin. Yung CO2 natin is 6, and our CO is 1.5, no? So, we have 6 pound mole of CO2 and 1.5 pound mole of CO. Now, ang kailangan nating makuha is yung ORSAT analysis natin, ano? So, let me write this again sa ibaba. Okay? Kasi doon natin i-calculate dahil medyo kapos na tayo sa space dito, no? So, our flue gas analysis is this one. So, we have, okay, so our flue gas is composed of the following, no? So, ito yung mga lumabas sa flue gas natin. We have CO2, we have CO, we have unused O2, we have N2, and then we have water. Diba? So, yung CO2 natin, nakuha na natin yan dito. We have CO2 6, CO 1.5, and H2O 5, diba? So, we have 6 of CO2, 1.5 of CO, and 5 of H2O. Now, our O2, which is unused, ito yun, 10.75 pound moles. And then, our N2, ito yun, kinalculate natin kanina, supplied N2, 75.24. Now, so we have 75.24. So, these are all in pound moles. Okay. And also, our water is in pound mole. Okay. Now, tulad nung napag-aralan natin last time, no, in getting the ORSAT analysis, we will take the percentage of all our component except for water. So, aalisin natin itong water. So, ito lang yung kukunin natin. So, kunin natin yung total pound mole ng ating mga gases except for water. Okay? So, we have 6 plus 1.5 plus 10.75 plus 75.24. So, we have 93.49 pound mole of our flue gas. Okay? So, kunin natin yung percentage ng bawat isang component, and that will be our ORSAT analysis. Okay, so kunin muna natin yung CO2. So, for CO2, we have 6 divided by 93.49, which is equal to 0.06. So, we will multiply to 100. We have 6.42%. Okay, for our CO, we have 1.5 divided by 93.49 times 100. We have 1.6%. For our O2, 10.75 divided by 93.49 times 100. We have 11.5. Okay, so we have 11.50%. And then, para sa ating N2, we have 75.24 divided by 93.49 times 100 is equal to 80.48%. So, 80.48%. Okay? So, this is our flue gas ORSAT analysis. Okay? So, I hope natutunan natin yung calculation natin if we have an incomplete combustion. So, we will be solving more problem sa upcoming videos natin. So, with all of that and more, I'll see you in our next video.